Hey, welcome back to your favorite trigonometry class. We're going to take a look at the ellipse. There's our objectives for today. Let's start out with the definition of an ellipse. So an ellipse is a collection of all points in a plane whose sum of the distances from those two fixed points called the foci are a constant. So if you look at this picture here, you see how we have the point on the ellipse. This distance from F2 to the point plus that distance right there. So that distance plus that distance is a fixed constant. It's a fixed constant. And if you can imagine, so it's a collection of all those points whose sum is a fixed constant. So if you can imagine if you have this staked down at the vertices here, or I'm sorry, at the foci here, you have it staked down, and you have a string here, and you just drag that string around, that'll create the ellipse, right? If you drag it around with a pencil and you keep it taut, if you will. Okay. So there's some characteristics of this and some vocabulary along with the ellipse. So we're going to call, if your major axis is horizontal, we're going to put the center right there at the middle, right on the origin initially. So here's our center right there. Our vertices, so if it's elongated horizontally, right, it's longer, and so the major axis is on the horizontal, is on the x-axis. This distance right here is a. From the center to the vertex, the distance from the center to a co-vertex is b. Distance from the center to one of these focus points is c. Okay, and again, this is our major axis because it's elongated horizontally. This is our minor axis where it's elongated. Or I'm sorry, when it's elongated horizontally, the minor axis is vertical. Okay. Now there's a little characteristic here I want to talk about. When we have this, let me draw this ellipse here. We've got the point here, focus 1, and I'm going to have the point focus 2. Now if I put that point, instead of the point being up above like it was before, let me put the point P right here. Right, that pencil if you will. Now, what I'm going to do, if you remember, that distance is A, that distance is C. So what is this distance from F1 to P? Plus, because we know this is a constant, the distance from F2 to this point P. This is a fixed constant K, but what is it? Well, the distance from F1 to P, this distance right here I'm going to call X, is A minus C. So that's A minus C. And then the distance from F2 to P is A, so that's this distance, plus we know that distance from the center to the focus is C, so A plus C. So the C's cancel, so this K distance is double A, 2 times A. Okay, that fixed constant. So that's one of the characteristics. Now, another relationship that you have between A, B, and C, let's say we put this point up here now, the point P, we put it up here at 0B. So we know this, since we have the centers right there at the middle of the origin, we know this distance from F2 to P and this distance is the same, right? The distance from F2 to P is the same as the distance from F1 to P. And we know when we add those up, right, when we make the summation of those two, F2 to P plus the distance F1 to P, we know that's K, which is 2A, right? So that's got to be A, and that's got to be A because they got to add up to 2A, and we know that they're equal. So now we have this triangle right here, this right triangle, And so we know that a squared equals b squared plus c squared. That's the relationship, and you're going to see it oftentimes written as b squared equaling a squared minus c squared. That's just a preference thing. But that's the relationship between a, b, and c in an ellipse. Okay? And remember, in an ellipse, when we've got the center at the origin, this is our distance a out to a vertex. Our co-vertex distance from the center out to the on that minor axis out to the co-vertex is b, and then the distance out is c to our focus. Okay, try and keep those straight. All right, so here's the equation that we have for an ellipse. If I put the center right at 0, 0, it's elongated horizontally. In other words, the major axis is horizontal. It's on the x-axis. Then I have x squared over a squared plus y squared over b squared equals 1. We know that's the relationship we just showed, b squared equals a squared minus c squared for an ellipse. And then a is always greater than b. In fact, sometimes you'll see it like that. Okay, a is greater than b. Okay, so the bigger number is underneath the x squared when when the major axis is horizontal. Let's do some problems now. Find an equation of an ellipse. Let me go back to my lovely blue. With center at the origin. Let's draw this thing. Center at the origin. I got one focus is at 2, 0, so here's a focus. And I have the vertex at 4, 0. So I don't know exactly what this looks like, but they're giving me a little information here. So it's elongated horizontally, so in other words, the major axis is horizontal. So the first thing I'm thinking of is I'm like, well, I'm trying to graph this equation and find the equation of this thing. I have x squared over a squared plus y squared over b squared equals 1. And I know a is greater than b, right? And I also know the relationship is b squared equals a squared minus c squared, right? Now if I look at my picture here, since this vertex is at 4, 0, my focus is at 2, 0, well that's saying that we got an a value that's 4, and then our c value, the distance from the center to the focus, our c value is 2. So number 2, I know a is 4, c is 2. Here's the relationship for an ellipse. B squared equals a squared minus c squared. So b squared equals 4 squared minus 2 squared. So b squared equals 12. Or b equals square root of 12, which really is 2 root 3. 2 root 3. Oops. Okay. So that tells me my b. So this is, 2 root 3. Square root of 12 is between 3 and 4, right? Square root of 9 is 3. Square root of 16 is 4. So it's about, 3.4, 3.5. So there's where my the point is for my covertex. So 0 comma square root of 12 or 0 comma 2 root 3. And then this other one is 0 comma negative 2 root 3. We know my other focus is at negative 2, 0. The other vertex is negative 4, 0. Right? But now we got the equation. We can write this equation. We have x squared over a squared plus y squared over b squared equals 1. X squared, I know my a is 4, so that's 4 squared. Y squared, I know my b is 2 root 3 or square root of 12, right? 2 root 3, if I just square that. In other words, b squared is 12, right? When I square that, that's just 12. And I got 16. So we got x squared over 16 plus y squared over 12 equals 1. That's our equation of the ellipse, and we've got that graph right there with everything labeled. And of course, these are also our intercepts as well, right? There's our x-intercept, there's our y-intercept, and so on, right? All right, let's keep going here. There's a little better picture of that thing. And by the way, I would not put square root of 12. Go ahead and put 2 root 3 on that. Alright, analyze the equation. We got x squared over 25 plus y squared over 16. Notice 25 is bigger than 16, so I know a is bigger than b, so I know that's my a squared right there. So this is of the form x squared over a squared plus y squared over b squared equals 1, which means the major axis is, the center's at 0, 0. The major axis is on the x-axis. Okay, the major axis is horizontal. Okay, so I'm going to start with saying, well, I know a squared is 25. So if a squared is 25, a is 5. B squared's got to be 16, so b is 4. Let's see if I can start drawing this thing. Center's at 0, 0. A is 5. No, it's elongated horizontally. B is 4. So my co-vertex is right up there, 0, 4, 0, negative 4. Now I can kind of draw this thing. The only problem is I don't know where my focus is, so I'm going to have to use the fact that I know b squared equals a squared minus c squared. Well, b is 4, so I got 4 squared. A is 5, I got 5 squared. In other words, c squared equals 25 minus 16, which is 9. So c is 3. So I'm going to count from the center, 1, 2, 3. I'm going to put my focus right there. So there's my vertex at 5, 0. The other vertex at negative 5, 0. Maybe I want to call that vertex 1, vertex 2. Focus 1 is at 3, 0. Again, it's a c distance away at 3, 1, 2, 3. So focus 2 would be at negative 3, 0. My co-vertex is up here. B distance away, it was 4 units away, was my B. So 0, negative 4 is my other co-vertex on that thing. So we can kind of draw that, alright? There's a better picture of that thing. Alright, what if your major axis is vertical? In other words, your major axis along the y-axis. Well, now the a, the bigger value, will be underneath the y squared. Okay, so it'll be of this form: x squared over b squared plus y squared over a squared equals 1. Okay, the distance from the center up to that vertex will still be a distance of a, though. Okay, notice these relationships: a is still greater than b. So let's go ahead and work a problem here with that. Analyze the equation. All right. First thing is, let's get this thing in the right form. With an ellipse, we got to have it, to put it in standard form, we're going to have it equal to 1. We want this number to be 1. So what we're going to do is we're going to divide by the same number. So we have x squared over 1. I'm going to put a 1 there so I know what that is. Y squared over 16 equals 1. So now I'm thinking to myself, oh, okay, that's the bigger number here. So this is of the form x squared over b squared plus y squared. That's my a squared, right? Remember, a is bigger than b. So a squared's got to be bigger than b squared, right? So my major axis is vertical now. My major axis is vertical. And I know the center's still at 0, 0. So I got center at 0, 0, but notice my a squared 16. A squared 16, so my a is 4. So I'm going to go up 4 for my vertex. That's my vertex, and then down 4. So there's one vertex, 4, 0. My other vertex is at, oh, I'm sorry, 0, 4. Good grief. The other one's at 0, negative 4. My b squared is 1. So square root, I got b of 1. So there's my co-vertex. 1, 0, negative 1, 0 is my co-vertex. I kind of draw this thing a little bit. Okay. Now the only other thing is the foci lie on that major axis. So they're on that vertical y-axis there. So I do need to find, let's look at red here. B squared, I need to find my c, right? So I know b squared equals a squared minus c squared. And so B is 1, so I got 1 squared. A is 4, so 4 squared or 16. So C squared equals 15. So C equals square root of 15. So that's about, I don't know, 3.8, 3.9. You know, it's between square root of 9 and square root of 16. It's between 3 and 4. So there's, oops, there's one focus. It says 0, comma, it's up square root of 15. 3.873 it looks like. And then here's your other focus. 0, negative root of 15, down 3.8, 3.9 kind of deal. All right. There's a little picture as well, a little nicer picture. Okay, for example 4 here, find the equation of the ellipse having a focus 0, 3, so we know a focus. Vertices is 0, negative 4, and 0, 4. Let's just draw this. Oh my gosh, that was awful. Let's not draw totally crooked. Yeah, it doesn't matter. I still draw crooked. Alright, vertices is 0, negative 4. The other vertice is 0, 4. Focus is 0, 3. So I know this thing. Oh man, I don't know B yet, but I'm just guessing. Okay, so here's a vertex. Here's a focus point. So I know the other focus got to be down here, 0, negative 3. Of course, there's my other vertex. So what's this telling us? If I know vertex 0, 4 and 0, negative 4, how do I know that the center's right there in the middle? Well, the center is going to be right between the vertices. So if one's at 0, 4, one's at 0, negative 4, I know that center's right there. It's 0, 0. So thus I drew that. I know my A must be 4. I know my C is 3 because they gave us the focus is at 0, 3, right? So A is 4. I know my C is 3. So I have B squared equals A squared minus C squared. B squared equals 4 squared minus 3 squared. So B squared equals 7. In other words, B is root 7. Well, root 7 is about 2.646 it looks like. So, you know, it's between 2 and 3, obviously between square root of 4 and square root of 9. So, you know what, I did draw that pretty good right there. Let me do what's wrong with this thing? There we go. Froze on me for a second. So B, there's our B distance. So that co-vertex is at root 7, comma 0. The other one over here is negative root 7, comma 0. Right, negative 2.646, comma 0. All right. So there's our little graph. The information we're given there. Notice our co-vertices there. And you know what? I'm going to stop it here and start a new one video. Thanks for listening.